Hi, and welcome to another exciting edition of CG Shader development. My name is Nate Nestler, and this is for Hyperactive Studios. Now, we're going to start going over ScreenSpace shaders, and ScreenSpace shaders are super cool because that is how a lot of the really awesome effects in games current day right now are being done. And it's also going to be how things are going to be done in the future too. So, it doesn't matter if it's current gen or next gen, we're going to be doing it this way for probably a super long time, if not forever. So, we'll see. But basically, it's a really efficient way of handling stuff. You can do things in ScreenSpace you would not normally be able to do on a regular object, just because it'd be too computationally intensive to compute every single object this way. But one of the things that's different here for ScreenSpace shading, on a regular object, you don't want to go beyond a single pass for a model, because if you do, you're actually accumulating extra executions in the processing cycles on the 3D program. And so in doing so, it costs a lot more money. Well, not a lot more money, sorry, but a lot more in hardware, which would translate to money. But basically, it's going to slow down the game significantly. So if you're sitting there running a whole bunch of passes and a whole bunch of shaders, you're not going to hardly be able to run anything in the game. It's just going to slow down to a halt real quick. But in the case of ScreenSpace, you're doing it for all the objects in the scene, not just a single one, and it's going to affect everything. So it's super cool and super awesome and powerful and very effective. So we're going to start looking at how to do ScreenSpace shaders, because it really does save you a lot of headaches and lets you do multiple passes on them, because since you're doing it for all the objects in the scene, just for the screen, you can actually get away with doing these multiple passes. So it lets you take on and doing more advanced techniques you wouldn't normally be able to do. Some of which fall more into the side of film, as far as those calculations and formulas and such. And we're taking what used to be a really long computation to be done for rendering in a film, or take hours or sometimes weeks to render. We're doing it in real time. For some of these passes and such. It makes the games look absolutely amazing when you do this. So we're going to be focusing on some ScreenSpace shaders, and then yes, of course, we'll pop back over and do normal. We already did normal mapping, but we'll do parallax mapping and relief mapping, and we're going to do a bunch of really cool stuff here. And we're going to move in some techniques. Currently, I have 8 written up. I'll probably do somewhere between 16 and 20 ScreenSpace shaders, but yeah, it's pretty cool, and we'll hop on it and get some stuff done here. So let's have a look at what's available and what we can do. Now, this pre-color one, after I code one of these, I'm going to give you a heads up. I'm having a problem with FX Composer 2.5. Maybe you won't, I hope not. But when I want to remove one of these ScreenSpace shaders, if I apply it, I need to Control Z to undo it, or Edit, Undo. And in doing so, sometimes it will remove lots of shaders at once. If that happens, you're going to come back here and go Edit, and then say Redo to bring them back. I don't know why it's doing that, but it is, which is annoying, but that's what's happening. I don't want to leave it on here, because afterwards, well, it's a bit of a problem for applying the next one. And I haven't found a real good way to apply the next ScreenSpace shader for testing and such without removing the other one. So if I hit Control Z, it lets me remove it, and it's about the only way so far I've been able to find of actually removing a ScreenSpace shader inside of Composer 2.5 from the scene. I can't find another way to remove it so far, so it may not be, I don't know. I'm sure I've tried a lot of things, but I can't seem to find anything that will actually just remove it. So, and since I can't seem to get a hold of the scene itself to remove something, then there's just not much we can do. So for removing it, yeah. So there's a couple different things we can do. We can do pre-ScreenSpace shader, or we can do a post-ScreenSpace shader. Pre means we're going to apply the ScreenSpace to the entire screen before we even start rendering any objects in the scene. Okay, so what the pre means. Post means we're going to apply the ScreenSpace calculation where we do something with the images after we've rendered our objects. So here we can sit there and do this as three different three different stages in the rendering pipeline. We do the pre here, which means we're going to do our calculations before the object gets rendered. Then we have the particular point in time where we actually render our objects, and then afterwards we can actually manipulate the final images we got from those objects after they've been rendered. And we can do that. And we'll look into a whole host of techniques. Oh yeah, I'm starting to think about some other ones I want to do. Yeah, we'll probably do at least 20 ScreenSpace effects. No doubt about it. Oh yeah, we'll probably do about 20 or more. Yeah, they're great. And they're super awesome. And yeah, we're totally doing a bunch of these. All right, so let's look at what we can do here with this one. So this one's real simple. We're starting out simple. We're doing a pre on this one. So we're going to actually do the calculation before it actually starts rendering our teapot here. And all I did is went up here and I just said teapot. You know, that's it. Nothing fancy, nothing amazing, but teapot will suffice for what we need to do. And then when I do this, this is really simple. I'm just going to drag and drop this into the background and it lets me set the color. Ta-da! That was it. And then I can come in here and change the color of the background interactively behind the teapot. That's it. I could come in here and say a sphere also, and you'll notice that the sphere is also drawn, but our pre-ScreenSpace effect is still shading the background blue everywhere around us. There we go. That was it. So it may not sound like much, and again I'm just going to hit Control-Z to undo. And okay, so I remove that shader again. Well, let me make sure that just to remove something else I need. Okay, good. Constantly worried about that. Alright, but let's look at what we need to do for making this effect come to life. Alrighty. So we're going to have a new section that we have not had in the past, and that is this script one here, standard global. We need this because we need to pass certain values over into FX Composer to let it know what it is we're trying to do. Since we're no longer doing just regular shading of an object, we need to tell FX Composer that we're not shading an object, but rather we are shading the screen. And it needs to know that. Otherwise, if it doesn't know that, it will assume that we're trying to shade a model and not the screen. So this is where the script right here comes about. So what we're going to say is float script here, colon standards, global, just like this, all caps. Then we're going to do our annotation here. So we're going to do a less than sign here. String UI widget equals, in quotes, none, in quotes, semicolon. String script class equals, in quotes, scene. This is very important. This means we're going to be manipulating the screen here, okay? In quotes, semicolon. Each one of these words actually means something, and they really matter, because if we're basically setting it up, telling FX Composer this is what we want to do. So we're going to manipulate the scene here, the screen basically, and not an object, okay? And script order, all right? So when are we going to run the shader, in what order? Well, we're going to pre-process this shader, and this is going to be a pre-process effect and not a post. So in doing so, this is going to happen before we start rendering our objects. So we got to tell it that. So we're going to have here for our string here, our script order equals, in quotes, pre-process, in quotes, semicolon. And then string here, script output equals, in quotes, color, in quotes, semicolon there. Yep, just like that. So we're letting it know that, hey, this is going to be a color that we're going to do. We're going to do some color manipulation. That's not too uncommon. Matter of fact, everything we've done so far has been color manipulations for our output. And then we also need to tell it what technique we're going to execute at the end of this whole thing to let it know what it is we need to do to make this thing run. So we're going to come in on here and say string script here equals, in quotes, technique equals technique 0, semicolon, quotes, semicolon. And then this is going to give us basically which technique to execute. And for us, this is what it is. It's technique 0 because I've been too lazy to change it from its default name. Close greater than sign equals 0.8 semicolon. There we go. And let's just work with that. That's fine by me. Alrighty. Other things to be interested in. We're going to do our background color. This will be the color of the background. Or, you know, basically the color of our scene, everything behind our teapot here. And that was that background color. So it's just float 4 here, background color, just like that. Open less than sign string here, UI widget equals, in quotes, color, close quotes, semicolon, and then string space UI name equals, in quotes, background space color, close quotes, semicolon, open greater than sign equals, in curly brace, it's a curly brace, 1.0 comma 1.0 comma 0.0 comma 0.0 close curly brace semicolon. This will give you blazing yellow of bright eye gouging color. Alright, so from here we're going to say float here, background depth. Okay, so we have to have a depth to it too. And this is just a grayscale value, so it's simple enough. We just open up our annotation with a with a less than sign. String UI widget equals, in quotes, none here, close quotes, semicolon, and greater than sign equals 1.0 semicolon here. So we're just giving our depth, we're giving a full value here for our background depth, and that works fine for us. Alright, and our in and out parameters, same as usual, but with a little less going on here. We only have to have the position of our actual vertices in the scene. Outside of that, we don't really care. We don't need UVs, we don't need anything. We don't need normals, nothing. So this is an incredibly simple structure as far as that goes. It's only one variable, which is position. And for the value coming in, of course, it's going to be a float 3 as always. And it's going to be a float 4 coming out. And it's just VS in just as usual, struct VS out as usual, and then struct FS out as usual, and then it's just float 4 color, colon, color, semicolon. That's it. And of course these are curly braces here, and a curly brace semicolon at the end. So this is all pretty much standard boilerplate, what we're used to doing here. You know, let me move this up. I hate having it down there. I told myself I wouldn't leave it down there, and then I did. Just because I like having my stuff up here, where I'm used to seeing it. Okay. And really I should have done a none on that annotation there too. Sorry. And this is be a widget here, just so we don't have junk showing up in here. That's why we're getting that world projection, and you know, I know better to do that than to do what I did, but I did it anyways. So, you know, that's how things go sometimes. Alright, compile, and there it goes, it disappeared now. Awesome. And so of course this is a float 4x4, and my apologies, I just put this up above the background color here. This is a float 4x4, same as always, Worldview, PROJ for projection, Worldview Projection here, colon, Worldview Projection, open less than sign here, string space UI widget equals, in quotes, none, close quotes, semicolon, and then closing greater than sign, semicolon. Alrighty. It should be boilerplate at this point in time. You should be very familiar with this technique and how to go about it. Okay. So continuing forward with manipulating the background screen. So we covered all this, and we're going to come down here now and just do our Vertex Shader. I'll tell you what, I'll even prove the fact that that works. See, still works. Make sure I go up here and make sure it's still in the same place after I hit Control-Z. It is awesome, great. Let me double check, make sure all my shaders are still there, good. Make sure it didn't remove them on me. Okay. So we need to do our Vertex Shader here. And VS out here, main VS here, open parentheses, VS in, space IN, close parentheses, open curly brace here, VS out, space out, semicolon. Oh, by the way, I also created a whole new project. I forgot to mention this. File, new project here, and it's called it ScreenSpace Shaders. I just called it that. The other project was getting too full, so I just created a new one just for ScreenSpace shaders, just to make life a little easier. Alright, but anyways, VS out here, main VS, VS in parentheses in, space in, close parentheses. This is the same as always. Open curly brace here, VS out, space out, semicolon, out dot position equals float 4. Here, open parentheses, in dot position dot xyz, comma 1, close parentheses, semicolon, and then we're going to return out. Okay, so we're going to return out here, semicolon, close curly brace. And this is our VS out now. Now we need to do our FS, or our fragment shader here. And so here, FS out, main, PS, open close parentheses, and then open curly brace here, and then FS out, space out, semicolon, and then we're going to go down here, same as always here, out dot color equals, in this case we're going to say background color. Very simple shader, semicolon, return out, semicolon. So it's just almost just like when you did your very first shader on the object, but we're doing it on the screen instead. Close curly brace, and then something a little more fancy here with our techniques. Alright, so technique, space technique 0, open and annotation. Whoa, what's this? This is new. Yep, sure is. String space script equals, in quotes, clear set color equals background color, semicolon, close quotes. Open quotes, clear set depth equals background depth, semicolon, close quotes. Now we set these up at the very top of our program. So if you look up here, this is where this came from, okay? So it came from when we created this earlier, and don't forget the background color is actually the color it's going to be of our scene. So yeah, we're saying, you know, for the background color, we're going to make this our clear color inside OpenGL, so that when OpenGL goes executed, when we first start the scene, we have to clear the scene with a color. This is the color it's getting set. That's it. It's that simple. And then we're setting out what our background depth is going to be based on our other value. So, you know, we have to set up the depth and the color when we initialize the scene every frame when we're rendering it in OpenGL. So that's what we're doing here. And this lets us clear out this space with a default color in the background, and we've set up our depth for all the other rendering. So it's important. Clear equals color, semicolon, and close quotes here. Clear equals depth, semicolon, in quotes here. Past equals P0, semicolon, quotes here. Alright, so we're setting our clear to a color, we're setting our depth to depth, clear to our depth now, so we're clearing a color, we're clearing a depth. And then no need for color clear, our technique will do it. So yeah, it'll do it right here, but whatever. Pass equals P0, so it's going to be this pass down here. And then script external equals scene here, semicolon, close quotes here, and close semicolon here. We have to do the semicolon at the very end of this whole list, because remember, this is actually all one line of one line command. But I've broken it up to where it's easy to read, because I don't want it to. If you want to help visually to notify that, hey, yeah, this is all one line, which a lot of people will do with something like this, where they'll indent it, just to help let people know that, hey, this is all part of this line here, and we're indenting it to let you know that this is all would be written on one line, but this would go off the screen. It would be annoying. And so, well, honestly, the best way to handle this to where it's readable is to type it out like this. So this is why you want to format your code, because if you don't format your code, this all in one line would be ugly. It'd be nasty. It is not something you want to do. So you want to do it like this here. Okay, then we have our closing annotation here of a greater than sign, and then open curly brace because we're starting our technique. Then we tell it we're going to do a pass P0 here, open less than sign here for doing our annotation here for this, and string equal, script here equals, in quotes, draw equals buffer, semicolon, quotes, semicolon. Now this is really important because we want to draw to our double buffer, so that way when it's done drawing it, it can get displayed onto the screen for the rendering process for each frame. So that's important. We do want to go to that double buffer. And then right here, the script, right here, we're saying we're doing it to the screen here when we said scene here, okay? So this is going to tell it to go to the screen. And then here after that, there's not so much to do. Closing greater than sign here, open curly brace here, depth test enable equals false, semicolon. Depth mask equals false, semicolon. Blend enable equals false, semicolon. Cull face enable equals false, semicolon. Depth func is equal to L equals, semicolon. It doesn't really matter. We're not using depth on this thing hardly. Vertex program equals compile ARBVP1 here, main VS, open close parentheses, semicolon. Why ARBVP? Well, simply, this works with the lowest profile. It's just a simple color, so of course it runs on everything. So I decided to make it just run on everything just by putting down this profile here, and now it'll work on everything you can imagine. Fragment program equals compile ARB FP1 main PS open close parentheses semicolon. And so this is setting up for our fragment program here to be ARB also. So again, this sets us up for fixed function pipeline compatibility. We work on everything. I mean, it's just a color for the background, so yes, it's going to run on everything. So nothing real surprising there as why that is. Closing curly brace here, closing curly brace, and that's the end of that effect. Alright, and then afterwards, of course, you're just going to want to drag and drop it after you save and compile, and you will need to compile it, but you're just going to go over here to your screen space, drag and drop, and bam, there's your color. Okay, now let's look at another one here. I feel like doing 2 of these in each video, because should be able to fit it no problem. These are pretty simple here at the start. Maybe once we get into the much more complicated ones, it might have to be a video per shader, because some can get kind of long with all the passes and everything in them, but they're so cool. They're just so cool. Right now you're going, yeah, I don't care. What's the big deal? Wait, just wait. We're going to do some God rays here. Already done it. We're going to do that in the next videos here pretty soon, where we have these light rays that are bursting out across your model. It's cool, where you can do a sun, and it's breaking through the trees or whatever. You've seen this before in reality, where you have smoke or something like that, and then it picks up the rays of light flying through the air. Those are called God rays or crepuscular rays, or sometimes referred to as light rays. Light scattering for the there's lots of names for it, but essentially it just comes down to the same thing, and we're just going to call it God rays because it's a nice name for it, and it's pretty cool. It does have like a holy effect to it, I think, pretty much for the look of it. But there's our ScreenSpace pre-color. Now we need to upgrade to having a texture in there. Okay. If I drag and drop this one to the background, we can assign a texture for our background now in our scene. So no more do you have to sit there and go, man, I wish I had something in the background other than just gray. Now you can have something than just gray. And it doesn't matter how many objects I have in here. Again, this is all being computed before the objects are calculated. Just want to show that off a bit more. Alright, going to remove that shader from the scene again. Double check that it didn't delete stuff I didn't want it to. Yes, it didn't. Good. Okay, so something we need to do, and this could be any image, it doesn't matter. Just grab an image and throw it on there. I just went with the image that came with NVIDIA. I don't care. Yeah, doesn't matter. Okay, so from here, let's look at it a little bit more. Daggone it. You know what? See, after I wrote one, the light, copy and pasted, of course, to the next one, just like I want you to do. So yeah, copy and paste this one here into your next one. You're going to call it ScreenSpace Pre-Texture. Okay, so go here to Create, Effect, CGFX, Next, Empty, and then in here you're going to type in your ScreenSpace Pre-Texture, .cgfx, then say Next and say Finish. Should pop up this. Copy and paste this one here into this one here, rename what you have happening there, make sure you date it, blah blah blah, write it up as such. Float script colon here, standards global, open less than sign here, string UI, well it's all the same. It's all the same as what we just did. So yeah, string UI widget equals in quotes none, close quotes, semicolon, string script class equals in quotes scene. Why scene? Because that's what we're doing. We're doing the screen here, right? Close quotes, semicolon. So remember, scene is the screen. Same thing. It's your screen. String script order equals in quotes pre-process, close quotes, semicolon. Now, something I should have mentioned. I'll mention it here in just a second. String script output equals in quotes color, close quotes, semicolon. And again, this is because we're pre-processing it. So this is happening before we render our objects. And then string script here equals in quotes technique equals technique 0, semicolon, in quotes, semicolon. And then close our annotation with a greater than sign equals 0.8, semicolon. Now, you're probably wondering, why did we have a vertex shader if we were just doing a color? Why didn't we just do a fragment shader? Okay, something I didn't mention. The way this works is it's actually a quad, polygon quad that's actually aligned to the screen perfectly. And we're basically drawing to that quad at the front of the screen. And that's how it's working. So that's how it takes up the whole screen. So we have to have our VS main here for positions for our quad that takes up our full screen here and resizes itself automatically as the screen resizes and all this, so that it fills up the space with color or whatever. So you'd have one, that gets calculated in behind the scene here for the image, for the final image before we rendered objects, and then for the post, same thing again. We're just hitting that same quad for the screen. So it's just a single quad. It's very simple setup. It's already set up inside FX Composer. You would have to set it up in your game engine. We'll worry about that later on when we go to implement ScreenSpace shaders in your game engine, which we cover in another series. And yeah, you'll learn how to do all that stuff. And we'll develop all that out to make it work, because that's the whole point of this, so that we're doing this here at this point, and then we'll go into the more complicated tasks later on of how do we set this up, how we make it do this type thing in an actual engine that you write yourself, and make it with current gen, next gen graphics capabilities, and we're going to add a physics system and all that. But anyhow, let's have a look at what we're going to do here. So I just want to point that out, that this is actually the reason why we wrote this vertex shader is because this is handling our quad that actually makes up our screen, and this quad is exactly fitted perfectly to our screen at all 4 points, perfectly aligned to the screen at all times. That's what's going on there. So that's why we have that. Okay. And then something else I forgot to do while I was at it is I meant to come in here and grab this, because I totally forgot to do it again, because that's something I would do. Because again, I want to put this up here. Well, before I get to the rest of it, I do want the standard global thing up here at the very top, just so I let it know what we're doing for the rest of the program here. Now, that's just like the first thing I want to run and do and execute in my script, is to let it know ahead of time what are we doing. Just good policy. Alright, so here we're going to have our float 4x4 here, Worldview Projection, Worldview Projection. It's the same as before. Open lesson sign here, string UI widget equals in quotes none, close quotes, semicolon, open greater than sign, semicolon, so nothing different here. Float background depth here, open greater than sign. I'll have to remove the other entry, I have it down below of this. Float background depth here, open less than sign here, string UI widget equals in quotes none, close quotes, semicolon, close greater than sign equals 1.0, semicolon. So there's our background depth. Alright, here's our textures. Okay. And they're probably as you remember them. Let me see if I can't go down and remove my other entry so it's not Yeah, don't write this right here. We'll come back, don't worry. No need to panic. Okay. So in the texture section is as you remember it. Exactly as you remember it, matter of fact. I just did the default color.dds and then I loaded a different image because I felt like it. I saw this one, I was like, oh, that's cool, I'll use it. Doesn't matter, you can load any image you want. But by default, I did that color green one from NVIDIA, so I didn't feel like hunting down a different image to put in there. It's easy, it was there, and I don't care, it works. So that's all that matters. So texture here, color here, texture, and it's capital C, capital T. Open less than sign here. String resource name equals in quotes default underscore color dot dds close quote semicolon. The other reason why I like to use these defaults is because you probably have them on your computer, so I don't have to worry about you not being able to find an image or something like that. If you put the stuff in, bam, it's going to work for you perfectly. So it just makes life easier. String here space UI name equals in quotes diffuse texture semicolon here, and then string here resource type equals in quotes 2D close quotes semicolon. So you can see it says diffuse texture, and I can come in here and actually select my texture as always. And of course I got rid of that annoying extra value in there I don't want to see. So makes life a little nicer. Alright. Sampler 2D space color sampler equals sampler underscore state. Open curly brace here. Texture equals in less than sign here. Color texture close greater than sign semicolon. Min filter equals linear map linear semicolon as always. Mag filter equals linear semicolon as always. Wrap S equals repeat semicolon as always. Wrap T equals repeat semicolon as always. Close curly brace semicolon. So this is the same as we've always been doing for our textures. We will be changing things up later on this because we have to for the ScreenSpace stuff, but this one can actually get away with just normal what we've always done for texture and it works fine. Okay. So there's all our texture stuff. And that's what was different from the previous shader. Not a whole lot different really. We're going to add our UVs here. So this is different. So float 4 here, UV colon text chord 0 semicolon close curly brace semicolon. So struct space VSN open curly brace here. Float 3 position colon position semicolon float 4 UV colon text chord 0 semicolon close curly brace semicolon here. Data passed from Vertex Shader to Pixel Shader. Yes, that is what we're doing. So struct here VS out open curly brace here, and again float 4 position colon position semicolon. Nothing's changed here, but what has changed is going to be our float. Oh, daggone it, I did this in a previous video and I totally forgot. Ah, man, you know what that means? That this one over here also has that mistake. It'd have to. No, it doesn't. Awesome, that was from previously. Yeah. In another video, I mistakenly, when I was copy and pasting them, I forgot to change the 4 to a 2 after I copy and pasted another entry, and in doing so, I had the wrong one. Yes, that should be a float 2, and yes, it does work when you do it properly. Prove it. See? It works. Okay, my mistake. My apologies. Let's make sure it didn't remove anything. Nope, it didn't. Good. Alright. So yes, that should be a float 2 and not a float 4. You shouldn't need float 4 for hardly anything for texture wise. There's definitely float 3 for cube. I'm trying to think if there's anything for float 4. But anyways, it doesn't matter right now. What really matters here is getting this set up. Okay. And close curly brace semicolon here. Now struct fs out, open curly brace here, float 4 space color, colon color semicolon, close curly brace semicolon. And this gets us set up with our color for our final image, which is going to be the image when we sample it. Okay, down to our Vertex Shader. You'll notice that it is almost identical to what you had before, but now we have this wonderful out.uv equals in.uv.xy semicolon. So this is new. So make sure you put that in there. Now it's going to go underneath the out.position equals float4 here in parentheses in.position.xyz comma 1 space parentheses semicolon. Alright. And don't forget your VS out space out semicolon if you didn't do that earlier. This is all the same though. We've just been doing this over and over again. Same boilerplate stuff here. VS out, your main VS, parentheses, VS in, space, in, close parentheses. Alright, and then we're going to end it up here again. Same as always. Don't have to change it. Return out, semicolon, close curly brace. And let's move on to the next part here. And that is the pixel fragment shader. Alright, so the pixel fragment shader is very cool. As always, it's going to actually give us our texture. Now, again, this is setting up our magical quad that is aligned to our screen, and now we've also added that it's going to have UVs. We're going to be assigning something to the UVs of this quad. This quad already has UVs on it. You would code the UVs in along with its normal direction facing the camera inside of OpenGL, and we'll get into that later on. And then that passes in from that object into your shader here, CGFX shaders. So basically what we're doing here is we're mixing this up to where we're taking this quad information in when we coded it over in our game engine, and then we're loading in certain attributes of it to the shader to manipulate then the output to the screen as part of the rendering process. And this really does make a huge difference. We're doing all kinds of stuff you couldn't even dream about doing back when on the older games. Technology with fixed function pipeline. So games have switched over to this, and everybody's ditched fixed function pipeline. No one uses it anymore. There's no point. There's just no point. So everybody switched over to this shader technology, and you have to know it. It is absolute must. And so the pipeline now is way more complicated than it used to be, and this is why we're breaking it up in parts and pieces so it's easy to digest. Because taking this all at once would be way too much for someone learning. Anyways, we're going to do our comment here. And by the way, my comments about how you're going to do it in OpenGL is also what you would do in DirectX. You'd also, clear out the color for the background, and you would, go in there and create your own quad that aligns to the screen. Doesn't matter. So if you're doing DirectX, same thing, nothing new there. Of course, this language works with both, so hey. FS out here, main PS here, open parentheses, VS out, space in, close parentheses, curly brace here, FS out, space out, semicolon, out dot color equals float4, open parentheses, text 2D, open parentheses, color sampler, comma, in.uv, close parentheses, dot RGB, comma, 1.0f, close parentheses, semicolon. Alright. Standard boilerplate color sampler. We're grabbing a pixel from the image to process it. And assign it to the UVs of our quad aligned screen space. Our quad that's aligned to the screen. And basically we're grabbing the pixels from the image to assign to the rendering of this on the screen. And this is happening, of course, all before we even start rendering our teapot. So that's how we get that yellow color, or the image, appears, and then you have your model in front of it. That's because we're processing this before we actually start rendering any models. And we're sampling all these pixels. So out.color equals float4 here, open parentheses, I already said all this, sorry. Text 2D, open parentheses, color sampler, comma, in.uv, close parentheses, .rgb, comma, 1.0f, close parentheses, semicolon. And so, yeah, that's going to do our texture. And remember, we're sampling this and processing this per pixel simultaneously across on the 3D card in parallel. So that makes a big difference for speed. Return out, semicolon, close curly brace here. This is a curly brace. And then we're going to do our technique here. And this is where things, again, are the same from before, but they are a little different than what we're used to. So technique here, space technique 0, open less than sign for annotation here. String script equals, and again, if you want, you can just tab these over to help make it more straightforward and apparent what we're doing here. Okay. And this should clear our set depth here is equal to background depth, semicolon, in quotes here, open quotes here, clear equals depth, semicolon, in quotes here. All right, and then we're going to open quotes here again, pass equals P0, semicolon, close quotes here, and then open quotes here, script external equals scene, semicolon, close quotes, semicolon, close our annotation here with a greater than sign, open a curly brace here, pass here, space P0 here, less than sign, string, space script equals, in quotes, draw equals buffer, semicolon, close quotes, semicolon, greater than sign here for closing that annotation. So again, we're making it go to what? The draw buffer here. We're telling it to go to the screen by saying the scene here. And then we're setting it with our background depth here. So we're setting our background depth. Notice we're not doing our background color. We don't need to because we're doing our image in its place, okay? And then we're going to clear our depth because, again, we don't need to clear our color because, again, we're not setting the color. And then, of course, we're just doing our pass 0 here. So I just want to point that out really quick. All right, so pass here, P0 here, our annotation. It's going to the draw buffer. Open curly brace here. Depth test enable equals false, semicolon. Same old, same old. Depth mask equals false, semicolon. Blend enable equals false, semicolon. Cull face enable equals false, semicolon. Def func equals L equal, semicolon. Now you should have all this from before. Vertex program equals compile ARB VP1. And then space main DS, open close parentheses, semicolon. Fragment program equals compile ARB FP1 main FPS here, open close parentheses, semicolon. Close curly brace, close curly brace. And that should be a pretty straightforward, clear implementation of how to do both of those techniques. So that right there is it. And once you're done, don't forget to hit save all. Don't forget to compile it like so. And then you're just going to drag and drop it to your screen here. And it should work. Once you're done, don't forget to hit Control Z and make sure it is not wiping it out for your other shaders here that you have in your scene. If it is, don't forget you can go to Edit, Redo to get it back again. So pointing that out. We're going to do a lot of stuff here with these ScreenSpace shaders. We're eventually also going to get into, I haven't done it yet, but I'm going to do it. It's not going to take much time to knock it out. I'm familiar with it already from before, from another shading language, GLSL, so it's no big deal. But I'm going to code up the ScreenSpace shader for ScreenSpace ambient occlusion. And we're also going to try to do night vision later here and HDRI lighting and yeah, a lot of cool stuff. Whole lot of cool stuff. We're also going to do deferred shading and rendering. That makes a big difference. It speeds up your game engine and it's really cool and very powerful. So realize we're going to do a whole lot of stuff. And then the very next video we're going to start doing, just as a highlight to let you know where we're headed in the next video, we're not going to do Rayla Blur yet, but we are going to do something that's pretty interesting. And not that one yet. Not that one yet, sorry. This one here. We're going to do this one right here where we can actually control and change the colors of your scene with a gradient. And we're going to learn how to do gradients, which is fairly straightforward from what you've been doing here. You know, and then there we go. Tons of ugly colors, but it certainly gets the idea across, right? So yeah, you're going to learn how to do this gradient here too in the next video. And besides all that, we're also going to do something a little bit different. And we're also going to do, oh, what is it here? Let's see here. Which one is it? I didn't do these in order. Probably pass through. I might do skybox. I haven't decided yet, but we may just do pass through instead. Where you start seeing environment maps. Starting to think about it. No, I definitely want to do skybox first. So yeah, we'll do the skybox one here. And then we'll do that in another video. So we'll do this one also in the other video, or how we get this image going all around our scene, and then we're just going to get into crazier and crazier effects in each video as we go on here. So realize you're getting into the more advanced area of the series here for the shader programming stuff, and so things are going to get cooler and cooler as we go through it. Some of the shaders are going to get a lot longer to go over as far as their coding, because their code's going to get a lot longer because there's a lot more happening in them. But the effects are absolutely amazing and they're just awesome. So totally worth it to go in through all the extra effort without any doubt. And I hope you're as excited and having as much fun as I am with coding this stuff, because this is going to get really cool and it's going to get really crazy awesome, because I do want to move closer to what we were doing some of the companies I was working at before for our shader effects and stuff like that on our game productions. So if I can sit there and push this closer to totally pro type coding on the techniques and such, probably won't go to the point of optimizing it to where it's super ridiculously fast. I may talk about some of that, but you know, basically the main focus here is to learn the techniques and to learn what it is we're doing and how it works and all that stuff, and then you can optimize later and make it better and all this stuff for speed. But you know, some of the stuff when you optimize them is hard to read and understand what's going on in the code, so simplifying it and breaking it down, well, it makes it easier to learn. So, you know, our focus here isn't optimization, I'm afraid. So, just FYI, let you know that. But anyways, alright, so that's enough for this video, and let's pop over into the next video and start doing those other shaders I just talked about. Alright, well, in that case, this was CG Shader programming for ScreenSpace shaders in this case. My name is Nate Nessler, and this is for Hyperactive Studios. Thank you very much.